Good afternoon. Now, yesterday we started our first basic chapter, that is probability. I'll just give you a brief of what we did yesterday. So probability is nothing but desired outcome upon total outcome. Now we can use probability with the same formulas that we have learned with sets. So yesterday we discussed a little bit about sets. In sets we say number of elements in A union B is equals to number of elements in A plus number of elements in B minus number of elements in A intersection B. Now when it comes to probability, we just divide both sides by number of elements in universal set, that is nothing but desired total outcomes, and we get probability. So basically we translate directly the number of elements formula directly into probability. Now here we are going to say that these are probability of an event. So probability of an event where the small letters that we use, that is the elements of the set, we call them as our outcomes. So probability of an event A with outcomes whatever we have. So A union B will be probability of A plus probability of B minus probability of A intersection B. We discussed other formulas like A union B union C. Again, that will be translated directly into probability. Instead of N, you will just put P. And then we took an example here. For the same thing, we said from a deck of 52 cards, one card is randomly chosen. Find the probability that first it is a club, so it becomes an event. So the outcome, so there are 13 clubs out of 52 cards. So probability of A would be 13 out of 52. Similarly, it is a 7, 4 sevens out of 52, 4 by 52. Then it is a club, 7 of clubs. When we say 7 of clubs, that just means it is a club and a 7. So that becomes intersection. There is only one such card, that is why 1 by 52. And it is a club or a 7. That means it is club or 7. That is union. So we have total such 16 cards that are 7 or a club and out of 52. So that becomes our probability. We proved that using this formula as well. Probability of A plus probability of B minus probability of A intersection B should give me A union B. Then we talked about mutually exclusive events. We say when two events do not have any outcomes in common, then they are mutually exclusive. That means intersection is 0. There's nothing in common between them. Mutually exhaustive events, when two events together share all possible outcomes amongst them. That means together they make up everything, that is the universal set. So probability of A union B will be equal to 1. This is how we set the limits of probability. The minimum probability can be 0, the maximum probability can be 1. So probability will always be between 0 and 1. Then we have independent events. We said independent events, if occurrence or non-occurrence of first event does not affect the occurrence or non-occurrence of the second event, then they are called as independent events. So we are saying if A occurred and B occurred together and they are independent of each other, then probability of them occurring together is nothing but probability that A occurred into probability that B occurred independently. Similarly, A not occurring, A complement is A not occurring and B occurring. Again, it is same as probability of A not occurring and B occurring independently. Similarly, A not occurring and B not occurring together, probability of that would be A not occurring into B not occurring independently. Okay, so these are all four cases. So if A and B are independent, this is what we see in terms of probabilities. Then we talked about an example where, have I written it as a question? Yeah, here. So in a deck of 52 cards, 3 cards are selected at random. Find the probability that all 3 are aces if first cards were replaced after each selection and second cards were not replaced after each selection. So what happens if I am picking a card and I am trying to see whether this is ace or not. Irrespective of whether this was ace or not, for the second card selection, now I have only 51 cards in the deck. So if I, without replacing this back into the deck, if I select another card, what would happen is my probability will change. But if I replace the card back into the deck before selecting the second one, then probability of selecting the second card remains exactly same. It will be same as first, second and third because we are replacing the card back before selecting the next card. So they are independent of each other. So we say probability of all of them coming together would be probability of A1, A2, A3, and that is what we got here. But there is another case where cards were not replaced after each selection. That means it's like from the deck I am selecting 3 cards. So when I selected first card, the deck was now of only 51 cards because I have already 1 card out. And if my first card was an ace, the probability of the second card in the deck, there are only 3 aces now left in the deck. So probability of the second card being ace will be 3 by 51. But if my first card is not an ace, it is some other card, it is 5. So then I have 4 aces in the deck left. So probability of selecting another ace in the second would be now 4 by 51. So it depends whether my first card was an ace or not. That would change the probability. So we drew a probability tree diagram. We said probability of selecting an ace in the first card is 4 by 52. And probability of selecting not an ace in the first card is 48 by 52. Now, if we selected the first card as ace, then probability of selecting the second card as an ace is 3 by 51. And probability of selecting second card as not an ace if we have selected ace in the first card is 48 by 51 because there will be 48 non-aces in the deck. Similarly here, if we had selected not an ace, then probability of selecting an ace in the second card is 4 by 51 and selecting a not an ace would be 47 by 51. Similarly, for the third one, we calculated the probabilities and each one of these branches are going to be nothing but the cases that may occur. So if I want probability of ace, 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 so then I will multiply these 3 probabilities. I will say it will be 4 by 52 upon into 3 by 51 into 2 by 50. Okay, so we got the probability here. But if I wanted any other case as well, if I wanted, what is the probability that I get two aces and then not a ace? So I have ace, ace, and then not a ace. This is the three probabilities that I will multiply. If I wanted not a ace, ace, not a ace, so that would be not, ace, and then not. These are the three probabilities that I will multiply. So these are all the permutations that are possible. I can get all three aces or I can get all three knots, or any of these permutations in between. And for each one of them, I can calculate the probability very easily. But of course, if I had a lot of selections, like here I had only 3 selections, and I had only 2 options in each of those selections. I had ace or I had not an ace. If I have 5 selections and I have 3 choices in each one of them, my tree diagram will be very long. It will be very inconvenient. So then, today we are going to talk about another method without using this tree diagram. We use combinations. I hope everybody has studied combinations. We say NCR, n factorial upon r factorial n minus r factorial. By any chance, if you have not studied permutations and combinations before, let me know. Okay, I will send you some videos. I have made small videos on these that will give you a brief idea about it. Okay. So NCR is nothing but n factorial upon r factorial into n minus r factorial. A few things that you should remember is NC0 is nothing but 1. R can only go maximum up till n, and both of these n and r should be positive integers. So NC0, that is also equal to NCN. And we have NCR is equals to NC n minus r. Okay. And maybe if you want NC1, that would be equal to n. Anyways, in our calculator, we can directly get combinations. So in our calculator, if you see that above division, you have NCR written. You can see here NCR written in yellow. Similarly, NPR written in yellow here above multiplication. So if you want to access these values, you would be using shift to access them. So what you would do is, you would say, let's say if I want to find 5C3, I want 5C3, say 5, then shift, combination is C, so that is division, and then 3. If I press equal to, I get 10, that is 5C3. Similarly, if I want, let's say 15, C5, I will say 15, then shift, and then division button, and then 5, that is 3003. If I want permutation, if I have, let's say 11C3, something like this, I will say 11, shift, multiplication button, and then 3, 990. So permutation and combination we can directly find with our calculators. We don't have to do any actual calculations with factorials or numbers or what. We can directly use combinations and permutations from our calculator. So here when we were talking about getting 3 aces without replacement. The probability of getting 3 aces is going to be, out of 4 aces, I need to select any 3. Upon, out of total 52, I need to select any 3. So these are the desired number of selections, and these are total number of selections. So I want all 3 as aces. So desired is, out of 4 aces, I need to select any 3, and total outcomes is going to be, out of 52, I have to select any 3. So here 4 shift C 3 upon 52 shift division, and you will see it is exactly the same answer. Okay, so Yami, I am yet to talk about how we will use permutation and combination. Right now you understand, for this we used combination.
Yes.
I'll talk about it, don't worry. There are more cases that I'm going to take.
Okay, sir.
Okay, so we'll use combinations to find the probabilities when we have without replacement or we have not independent values, right? Now for the same question, again in the previous question, write without replacement if you don't, without replacement. So we're talking about without replacement right now. So we are taking 2 were aces and 1 not ace. Now if we see the tree diagram, if I say 2 aces and 1 not ace, I have, this is one branch, but I have other branches as well. This is also another branch where I am getting 2 aces and 1 not an ace. And also this is one branch where I am going to get 2 aces and 1 not an ace. These are the 3 branches where I am getting 2 aces and 1 not ace. It is much more clearer if you see here, right? AAN, ANA and NAA. 2 aces and 1 not an ace. So all of these three cases are the same, that we have two aces and one not ace. So probability of that, I will just write it here so that it is visually easy. Will be 4 by 52 into 3 by 51 into 48 by 50. Basically 4 into 3 into 48 by 52 into 51 into 50. Then either this will happen, either I will get AAN or I will get ANA. So whenever we have OR, we will add. Whenever we have AND, we will multiply. So we have A and N. So that is why we multiplied their probabilities. But either we will get AAN or we will get ANA. So we will add their probabilities. So I have 4 by 52, 48 by 51, and then 3 by 50. 4 into 48 into 3, 52 into 51 into 50. And similarly, the third case is NAA, or this third case will happen. That would be 48 into 4 into 3 upon 52 into 51 into 50. Basically, these are all three exactly same cases. All three are exactly the same cases. Probability, forget about cases. These are probabilities are exactly same. 4 into 3 into 48, exactly the same in all three. Denominator is also exactly same. So probability of all of these three cases are exactly same. So I can say from tree diagram, probability of two aces and one not an ace, the probability I'll get AAN plus ANA and AA. That is basically 3 into 4 into 3 into 48 by 52 into 51 into 50. Zero point 0.0130317. So this is using tree diagram, but as I said, tree diagram is not very practical every single time. We can also use combinations. In combinations, it's a probability of 2A and 1N is going to be out of 4A, I want to select any 2, and out of 48N, I want to select any 1, upon in total I want 52 C3. Out of 52, I am selecting 3 cards. Four, shift division 2 into 48, shift division 1 upon 52, shift division 3. And you can see it is exactly the same probability. It has to be, because they are the same calculations. Right? They are the same calculations. And the second one, can you see the difference between the first part and the second part? First part we said 2 were aces and 1 was n, not an ace. The second part we are saying first 2 were aces and last was n. So when we said 2 were aces and 1 was n, it did not matter where that n was. We said 2 of them are aces and 1 of them is n. But in this case, we are only talking about this first case, that is AAN. We are not talking about all 3 cases. So actually, when I said 2 were aces and 1 is n, that became a combination. I am making a combination of 2 aces and 1 n. It did not matter how they are arranged, because arrangement comes into permutation. So this probability AAN, this is a single permutation. This is a single permutation. So when we talk about AAN, we are only talking about 4 into 3 into 48 upon 52 into 51 into 50. Only single of them, not 3. That is one single permutation. So if we are taking one single permutation, for formula also we will take permutations. So we will take only permutations in the numerator, not in the denominator. So we will say 4p2 48p1. Actually, let me think about it. Actually, we will have permutation in the denominator. Let me just confirm it once with the formula, then, because I get confused sometimes. Yes. So we are going to take permutation in the denominator as well. So we'll have 52 P3. So the whole formula is for permutation. So again, you can use tree diagram or whatever method you want to call this one by taking the probabilities, or you can use permutations when you are talking about only one single arrangement out of all. I'll give you a question, example another. Out of 20 actuaries and 30 accountants, a group of 5 was made by random selection. Find the probability that in a group we have 3 actuaries and 2 accountants. Now see, when I say the group of 5 was made, we are not going to replace one person back into their group to select them again. It's not possible. So when I select a first person, let's say first person selected was an actuary. I cannot say go back into your group so that I can select again. That is not how people would work. I can do that with cards, but I cannot do that with people. So when I'm saying I'm selecting a group of 5 people, that means replacement is not possible. So this is without replacement. That means they are not independent of each other. So I'll use combinations. Because I do not want a particular arrangement. I only want 3 actuaries and 2 accountants. I don't care whether which one was selected first and which one was selected second. So I just want combinations. So probability, you can say 3 actuaries and 2 accountants. I will say out of 20 actuaries, I am selecting any 3. And out of 30 accountants, I am selecting any 2. And out of total 50 people, I am selecting any 5. Any problem here? I hope so, Yami, now you understand where we will use combination and where you will use permutation, right?
Yes, sir.
Good. Okay, so next, talk about conditional probabilities. First, I'll write down the formula and then I will explain what that is. So, now that is not AIB, that is A straight slash and then B. That is called as a straight slash. This is a backward slash, this is a forward slash, and this is a straight slash. So we put straight slash. And we say it is probability of A when B has already occurred. Okay, conditional probability is when something has already happened, what is the probability of something else happening? So this is probability of A occurring when B has already occurred. Okay. We also say it as probability A given B. We'll use the term given for this straight slash. Probability A given B. So we say probability of A given B is probability A intersection B upon probability of B. That's the mathematical formula of conditional probability. I will just take an example. We are saying one card was selected randomly from a deck of 52 cards. Find the probability that the card is a 7 if we know that the card is a club. So we are saying that we have the given information that the card is club. So let's say I select the card and I see that it's a club. I tell you that it's a club, but I don't show you which card it is. Ask you now, what is the probability that it is going to be a 7? So now so now you know that there are only 13 clubs. So I can have any of these 13 cards. And out of those 13, there is only one that is going to be a 7. So the probability is going to be 1 by 13. So if I say A is selecting a 7, B is selecting a club, then what we are finding here is probability of A given B. Probability that the card will be a 7 when we know it is a club. So first of all, I will just write down their individual probabilities. Probability of A is 4 by 52. I am not simplifying it. Probability of B is 13 by 52. And probability of A intersection B is 1 by 52. There is only one card, that is 7 of clubs. So now I want probability that the card will be a 7 given it is a club. That becomes probability A intersection B on probability of B. So logically also we could understand that we will have 1 by 13 chances, and mathematically also we are getting the same thing. That is conditional probability. So you may feel like, why are we using mathematics when we logically could understand what's going on? But when it becomes more and more complicated, then this conditional probability is helpful. Like here, when we made this tree diagram, this probability is a conditional probability. We'll say it is probability of getting a not card in second selection given we got an ace in the first selection. So getting a not card in the second selection given we got ace in the first selection, that probability is going to be this. Similarly, this probability is probability of getting a not card in the third selection given I got ace in the first selection and not in the second selection. So these are nothing but conditional probabilities. We know the previous information, only then we can calculate this probability. So conditional probability. And conditional probabilities are very useful. Later on also we are going to use conditional probabilities a lot. Next we'll talk about law of total probability. Here we'll have some assumptions. We have two assumptions here. First, we are saying let there be n mutually exclusive and exhaustive events E1 to En. When I'm saying they are mutually exclusive, that means they have nothing in common. So I can say probability E1 intersection E2 is same as E2 intersection E3 and so on till last, let's say En minus 1 intersection En. All of them are going to be 0. So every possible combination is going to be 0 except for the value where E1 is equal to E1 or E1 intersection E1 should not be 0. So I'll say summation, sorry, not summation, say probability EI intersection EJ is equals to 0 where I is 1 to n and j is less than I. So here I have not taken equal to, because clearly if j is equal to I, it becomes like E5 intersection E5, that will give me E5. But I have taken only less than, not greater than, because if I take E2 intersection E5, it will be same as E5 intersection E2. So I don't have to consider them again and again. So that is why I have only taken less than. I am not taking the greater than values. Then mutually exhaustive, that means together they should make up the whole universal set. That means probability E1 union E2 union En, that will be equal to 1. The way we write this as similar to summations. So you'll say probability of union I going from 1 to n ei will be equal to 1. The way we write summation, the same way you can write union or intersection as well. So these are the assumptions of our first one. For the second one, I'll just draw a diagram. So Venn diagram, let's draw a Venn diagram. Now when I say I have n mutually exclusive and independent events, they would look something like this. We'll say this is E1, E2, and so on till En. So they are mutually exclusive, that means they have nothing in common, and they are exhaustive events, that means together they make up the whole universal set. Now I have event A that have some or all elements, whatever, some common elements between them. So this is my A. Now my law of total probability says that if I want to calculate probability of A, I can calculate them as these sections. I can say it is this section plus this section plus this section plus this section, right? I can add them individually to get probability of A. So I can say probability of A can be written as probability of A intersection E1, A intersection E2, and so on till A intersection En. And we also know the conditional probability. So if I rearrange, I can write this as probability of A intersection B is nothing but probability of B into probability of A given B. So similarly, A intersection E1 can be written as probability of E1 into probability of A given E1 plus probability of E2, probability of A given E2, and so on, probability of En, probability of A given En.
सर अगर इवेंट म्यूचुअली एक्सक्लूसिव है तो पी इंटरसेक्शन बी तो 0 हो जाएगा.
See, when we say mutually exclusive, then E's are mutually exclusive, right? A is not mutually exclusive with E. We specifically said that event A have shares some outcome with some or all of E1 and En. We specifically said that E1, E2, these are all mutually exclusive. See, this is how we do this. So when I'm saying mutually exclusive, that means there is nothing common between E1 and E2. But A has common with E1, A has common with E2, A has common with En, all of them. I'm adding up all that common part. These are common part, A intersection E1, A intersection E2, A intersection En.
Yes.
So I'm just saying A does have things common with E1, E2, E3, but E1, E2, E3 do not have common between among themselves. So this I can say probability of A can be written as summation I going from 1 to n probability of EI into probability of A given EI. Make an example for this. Okay, instead of writing white and black, I'm just writing W and B. Okay, so 7 white and 3 black. We are saying there are 3 bags containing 10 balls each. The first bag is twice as likely to be selected as the second and the third bag. So in a way what I am saying is, let's say the bags are E1, E2, E3. This is E1, E2, E3. So what I am saying is probability of E1 is twice as probability of E2 and E3. So basically it would be 2 by 3. This would be 1 by 3. Actually no, sorry, 2 by 4, 1 by 4 and 1 by 4. So probability of selecting the first bag is twice as second and the third. 2 by 4, 1 by 4 and 1 by 4. Together they should make up 1. Total probability should be equal to 1. Then we are saying that the first bag contains 7 white and 3 black balls. I have 7 white, 3 black balls. Here I have 5 white, 5 black balls, and here I have 3 white and 7 black balls. So we are saying find the probability that a person selecting a ball at random will select a white ball. So in total, you can see we have 15 white balls and 15 black balls. So can we say that probability of selecting white ball will just be half? Because half of them are white and half of them are black. Does that make sense? This is correct in a particular sense. This is an approximate answer. Okay, approximately we are correct that the probability of selecting a white ball is going to be half. But it will also be affected by the probability of selecting a bag. You can imagine that this first bag, see, I don't know how many white and how many black balls are in a particular bag. But the first bag is kept in front of me. The other 2 bags are, a little bit behind. So I'm more likely to choose the first bag than to choose the other 2 bags. Then because I'm more likely to choose the first bag, I will randomly select the ball from this. So I'm more likely to get a white ball than a black ball. Correct? So probability of getting a white would be slightly higher than probability of getting black. But when I say that I am more likely to choose the first bag, does not mean that I will not be selecting the second bag, or does not mean that I will not be selecting the third bag. I can select the second bag also. There is a 25% chance that I will select the second bag. And if I select the second bag, there is 50% chance that I will get white or black balls. So then probability will be this. But there is also a 25% chance that I will select the third bag. If that is the case, then I'm more likely to select a black ball than a white ball. So if I want to understand without knowing which bag did I choose, if I want to know what is the probability of selecting a white ball, I should take the probabilities of selecting the bag into consideration also. So we'll say probability of selecting individual bags, we already know. And probability of selecting a white ball, given I chose the first bag, is going to be 0.7 because 7 out of 10 balls are white. Probability of selecting a white ball given I chose the second bag is going to be 0.5. Probability of choosing a white ball given I chose the third bag is going to be 0.3. 3 by 10. And now probability of white ball is going to be probability that I chose the first bag, and after choosing the first bag I chose the white ball, or probability that I chose the second bag, and after choosing the second bag I chose a white ball, or probability that I chose the third bag, and after choosing the third bag I chose a white ball. That is what our law of total probability says. These two things are happening together, that is why we are multiplying their probabilities, and this are alternatives of each other. Either I chose the first bag, chose a white ball, or I chose the second bag and chose a white ball. So that is why we have addition in between. So basically 0.5 into 0.7 plus 0.25 into 0.5, 0.25 into 0.3. So see, approximately we were correct. Approximately we have about half, or we have about 50% chance of selecting a white ball. But more accurately, we have 55% chance of selecting a white ball. If I did not give you the information about bag, if I just said there are 15 white and there are 15 black balls, what is the probability of selecting a white ball? You would have said half. You would have said 50%. But then I give you information, they are kept in 3 different bags. This is how the bags, this is how the division of the balls are. This is how likely are you to choose a bag. Now tell me what is the probability of selecting a white ball. So then you would say it is 0.55. So what has happened here is I've increased the complication and I'm getting more accurate answer. This is what happens throughout statistics. Throughout statistics, we are juggling with how much accuracy do we want and how much complications are we ready to take. The more complications you take, the more accuracy you would get. But it may not make a big difference. Because if I wanted to make a decision whether I would get a white ball or whether I get a black ball, here it might seem like I'm getting more times I'm getting a white ball compared to a black ball. But in decision making, it does not make a big difference whether I'm talking about 0.5 or whether I'm talking about 0.55. I'll say it's still, half of the times I'm getting white, half of the times I'm getting black, slightly more than half of the times I'm getting white. If I want to guess next time whether I will get a black ball or a white ball, there is very less chance that I will select it accurately, or you will say only half of the times I will be able to select it accurately. So even though we got more accurate answer here by increasing the complication, it may or may not be beneficial. It depends on, whether our decision is very important or not. If let's say we are just playing a game where we are betting, I may lose money, I may win money, it does not make a big difference. But if this is a medical problem, if this makes a big difference in whether the person will be able to live properly or not. then we would want more accuracy. Correct. So it depends on the situation, depends on your objective, whether you would go for more complication so that you get more accuracy, or whether you're okay with less complication and take less accuracy and still get an informed decision. Because finally, why are we studying probability? Why are we studying statistics? We are trying to use probability to understand what may happen in future. We can never predict the future perfectly, but we can make an informed decision. That is our goal. We want to make an informed decision. So if we have understanding of what may happen, how likely is something to happen, we can make a better decision. Like if I ask you in World Cup, will you expect, Bangladesh to win the World Cup? You might say no. Right? Why? You will say, I have seen their past performances. The chances that they would win are very less. That is nothing but the probability. That does not mean that Bangladesh cannot win. They can. If they play good on that day, what happens? It does not, we may not know. Right? If they consistently play good, they would win the World Cup. But the chances are very less. If you are supposed to bet on it today, you may bet against Bangladesh. Because probability is very less. So what you're doing is, you are making an informed decision about the future. You may or may not be correct, but because you have used the informed decision, most likely you will be correct. So all of the financial world is just betting on what may happen in the future. Right? That is what we are trying to figure out every single time. We cannot predict the future, but the closest a person can come to predicting the future would be an actuary, because we use statistics to understand what may happen in the future. Okay. So for today, if you have any other question, we'll not study anymore. There is still a small topic left in this chapter. We'll do it next Saturday. But let's talk about the timings and stuff.
Sir, in this question, we can't take 1/3, 1/6, and 1/6 as a probability.
Where?
So we have taken 2/4, 1/4, and 1/2.
So
अगर सर इक्वल प्रोबेबिलिटी देखेंगे तो 1/3, 1/3 और 1/2 होगी। और वो ऐसा है कि ट्वाइस बाय ऑफर हो रही है, तो सर इसमें जो सेकेंड और थर्ड का है उसकी 1/6 और 1/6 नहीं ले सकते।
See, what happens is, we would want probability E1 plus probability E2 plus probability E3 to be equal to 1. Total probability should always be equal to 1. Because there are only 3 options, you cannot choose a 4th bag. Okay. So then you will say probability of E1 is twice of probability of E2, and probability of E3 is same as probability of E2. So let's say I'll just write it as P. This is 2P, this is P, and this is P. Okay. So now you have 4P is equals to 1, so P is equals to 1/4. So this becomes 1/4, this becomes 1/4, and this becomes twice of that, that is 2/4. Okay. So next Saturday, we will have lecture 3:30 to 5:45 p.m. and Sunday we are going to have 9 to 11 11:30. No, not 11. Let's assume, I think we'll go till 11:15 most likely. We may extend it to 11:30 depending on, um, how much we are studying. Okay, this is going to be our usual timing. Now, I'll also take 1 day for doubt session. Doubt session will not start from the next week, but in a few weeks. Okay, so 1 day I am going to take for doubt session, and most likely it's going to be a Thursday. Not this Thursday, Thursdays later on. I'll inform you when the doubt sessions will start. Next class will be directly on Saturday. Okay, so Thursday, 6 to 8 p.m. so that you don't have, I hope by that time all your colleges will end and you'll be back home. So this is going to be our timings. This Thursday is going to be doubt sessions. So we are mostly going to study Saturday, Sunday only. And whatever I give you homework on Sunday and stuff, we'll discuss it on Thursday. You may revise your lectures and then realize that I did not understand some concepts. You can ask me on Thursday and we can revise it. So we'll keep Thursdays for doubt session. Yeah. Okay. Okay, Sunday this is AM. Sorry, Sunday this is 9 to 11:15 AM. Okay, my mistake there. So this is going to be our timing. Now this was our last demo lecture. So I hope you understand the way we are going to teach and how we are going to conduct our lectures. I want to also inform you that we use Google Classroom. So as soon as you pay the fee, see, you have the number here, the office number. You should contact Deepak sir at office. He is our manager. He is going to add you to a Google Classroom. I am going to show you how Google Classroom works. So first of all, there's an app. In your phone, you should download the app of Google Classroom, log in with the ID that you are going to provide us. We are going to send you an email through that, what do we say? Email ID. We are going to send you an email through Google Classroom so that you can join the class. Okay. So when you join the class, you are going to see a stream. You can see here stream. So this is the place where we are going to share any updates with you, updates about our course, update about our timings and everything. Okay, and you can ask me anything here as well. Okay, so you can share something here, I can share something here, you can reply on it and everything. Okay. Then this classwork section is where we share material with you. Okay, so we have the course material. We'll give you the revision notes. We'll give you chapter-wise assignments. Then all the recorded lectures will be shared here. So the recorded lectures, each lecture will be recorded and it will be shared with you by the end of the day. So, and all the details of what we have done in the lecture is shared in a sheet like this. So this is the last session. This is September 2023 session. So this is not your sheet, but the same thing will be done for you as well. So if I click on that link, you will find that on what date, what happened, which chapter was conducted, which question from an assignment was done or book question was done in that particular class, test question was done, these kind of things. We you have everything listed here, so that later on if you want to refer, like I don't understand how did we do chapter 12 question number 1, so you can just refer to this, go to this date, and you can see each of these classes have dates on it, and you can search that date and view that particular question. So each class would be recorded and shared with you. Then later on we'll be starting R programming. We'll be starting R programming in our regular lecture, most likely Sundays. Okay. But it will be starting after we are done with chapter 6. Okay, after we have completed chapter 6, we have started chapter 7, then we'll be starting R programming. So I'll inform then what we are going to do. We also share chapter wise tests. Okay. You can download the test and then submit the test in Google Classroom itself. Okay. Then these are the mock papers. Every session we make a mock paper, and all of the mock papers are available with you. This time also I'll be making a mock paper, and before the examination it will be available to you for practice. So this is how we share material, we share tests with you, we share the recorded lectures with you. If you have any other question, you can ask me. If that is it, we'll end the class here. If you have any other question, you can always contact us. You can note down the number. This is our office number. Deepak sir will be available on that number and would be able to clear your doubts. Okay. So let's end the class here and we'll meet next Saturday.